Okay, well, I thought I'd finished up all of these videos, but I ran too long on that other one, so now I have to go back and do 7.6 and 7.7. Let's try to do it fast. I already wrote all the notes. Come on in, follow along with me. Walk this way. Walk any way you want, but follow me. 7.6 is about solving these things. So we end up with radical 4a plus 1 equals 1. To solve, we're going to square both sides of this equation to eliminate the radical. End up 4a plus 1 equals 1. 4a equals 0. a equals 0. If you put that in here, 0, 4 times 0 is 0 plus 1. Square root of 1 is 1, so we're done. Here's a little harder one. That's easy. Here's a little harder. The green. Square root of x plus 4 equals the square root of x minus 2. This is separate. This is the square root of x minus 2. We're going to square both sides again. So when we square both sides, over here, easy, x plus 4. When we square over here, it's a little more complicated. It's x squared times x squared is x. And then negative 2 times radical x twice is negative 4 radical x. Negative 2 squared is 4. So then what I did is I subtracted 4 from both sides and subtracted x from both sides. I get 0 equals negative 4 radical x. Divide both sides by negative 4. Radical x has to equal 0. Also, no, that's not true. Not in this section. We don't see this yet. But we do in section 7.7. And that is imaginary numbers. Can you picture it? No, you can't. They're imaginary. You have to imagine them. Just like Walt Disney was an imagination guy. And a few other things. But imaginary numbers. The one we deal with is I. I is an imaginary number. But it represents something. What it represents is the square root of negative 1. Thus, you have these. I to the first, I to the second, I to the third, I to the fourth. Memorize these. I'm not going to go over them, but memorize them. You don't need that either, because you're memorizing them. Next, now we're going to talk about complex numbers. Complex numbers are made up of real numbers and imaginary numbers. Real numbers plus imaginary numbers gives you a complex numbers, not hashtags. Complex hashtags would not be appropriate. So, here's the rule. If, or rather, a plus bi equals c plus di, if and only if, that's from geometry, a equals c and b equals d. How do you use that? I'm going to show you. So, it's on the next page. Here it is. If 3 minus 4i equals negative 2x plus 8yi, that means that 3 equals negative 2x and negative 4 equals 8y. So x equals negative 3/2 and y equals negative 1/2. That's how you use it. So memorize it. Whoops, I ran into the wall here. So maybe we can move down some more. Oh, there it comes. So we can also add these things together. We can have 3 plus 5i plus 6 minus 2i. These are complex numbers. We're adding two complex hashtags. Two complex numbers, you add the real part, 3 plus 6, and the imaginary part, 5i minus 2i. And you get 9 plus 3i. You got it? That's what it comes out to right there. Imagine it. Imagine it? Never mind. So let's go over here now. Or maybe we'll just come in over here. You can also multiply complex numbers. This is a complex times this complex number here. So you get 3i times 4 is 12i. 3i times 5i is 15i squared. But what is I squared? Well, if I is the square root of negative 1, when you square it, you get negative 1. So you end up with negative 1 times 15 is negative 15. So this is your final answer. Right there. You can also multiply two complex numbers. Instead of that monomial here, we got two binomials. And we're going to do FOIL. Everybody loves FOIL, right? Except the charade, but never mind. So we get 2 times 3 is 6. We get 2 times I is 2i. Negative 4i times 3 is negative 12i. And negative 4i times I is negative 4i squared. There's that I squared again. My i's are round, but anyway. So I squared is negative 1, so we get negative 1 times negative 4 is 4. When we combine this part here, we get negative 10i, and then we can combine these two. Final answer, 10 minus 10i. So that's multiplication. And one last example, because I want to go home. One last example. I'm going to do it this way. It'll take a while to bring this all the way down. And this involves what we call the complex conjugate. Remember, conjugate we used in a former section to get rid of radicals in the denominator. Complex conjugates are going to get rid of the complex number. That is, we're going to get rid of I. We don't want I in the denominator. So we multiply by 1, but in this case we're going to call it 2 minus I because this is 2 plus I. If we didn't do that, then we would still have I in the denominator. So what happens is we get negative 3 times 2 is negative 6. Negative 3 times negative I is positive 3i. On the bottom we get 2 times 2 is 4. Then we have 2 times negative I, negative 2i. And then I times 2 is positive 2i. And then I times negative I is negative I squared. There's that negative I squared again. So, what does that become? This right here cancels each other out. So we end up with 4 minus negative 1, which it becomes 4 plus 1, which is 5. So the denominator is 5. The numerator didn't change. It is still negative 6 plus 3i. And there you have chapter 7. And I'm going home because it's way past your bedtime. Well, some of you are already asleep, I noticed. So, anyway.